Linear versus exponential. Dun, dun, dun. It's the best thing since Batman versus Superman. And this is part one. To construct models, we are going to need two things. We always need an initial value, and we need to know whether it's relative change or absolute change. And that's because if it's by a percentage, right? So we would know this is relative change. That means we have an exponential model. So when you're looking at something and it's like, oh, it's a 6% increase, that should send off an explosion in your brain that says exponential model. And if it's increased by a fixed number, so like my salary increased by $50 a month, absolute change tells me linear. Oops, spelled that wrong. And the absolute change is your slope. So whatever the change is, if that's like, oh, I increased $50 a month, great. That's my slope, 50. Loving that. Okay, let's do it. To attend a high school sporting event, one must pay $5 to get in the door and pay 75 cents for each concession stand item. Is this linear exponential model, and how do we know? Well, what do you know? Well, we have an initial amount. Well, that's good. But both exponential and linear have an initial amount. So that's, only so great. And then we look at 75 cents for each concession. Is that a percent or is it constant? Is it a number? It's a number. That means it's absolute change. That means it's my slope. That means it's a linear model. It's linear because of the number being the constant change. So let's construct a model. Well, my initial amount is going to be B. My slope, we already said, is 0.75. So y equals 0.75x plus 5. We have our model. Austin attends the sporting event and purchases 2 concessions. 2 concessions. That means x is 2. How much did he spend? Y equals 0.75 times 2 plus 5. You multiply first, so 1.5 plus 5. Austin spent $6.50. I hear students every semester say, oh man, I don't really know how to do this. Even if you struggle with constructing a model, you all can figure this out. Because you're like, oh, I paid $5 to get in the door, and then I bought 2 concessions at 75 cents each. Even if you don't use the model. Okay, so use your common sense even if you struggle with the equations. Moving on to number 2. High definition, words matter. High definition TVs are averaging $1,500 currently, but costs are decreasing at a rate of 15% per year. Is this linear exponential? 15%. It's a rate. It's happening per year. It's a percentage. It's exponential. And I know because it's a percentage. So we have our initial value. And now we have a percent. So what is our model? So thinking through exponential models, I know that I start with my initial. This is decreasing. So my decay rate is 1 minus the percentage raised, in this case, to the number of years. So 1 minus 0.15, my final would be 1,500 times 0.85 to the x. So remember when you're doing exponential, you either have 1 minus or 1 plus, depending if you're increasing or decreasing. But your percent comes in after that. So we have our model. Use guess and check to determine how many years it will take for TVs to be half their original cost. So I'm looking, I want Y to be $750 because that's half the initial cost. Now there's a couple different ways to do it, but it might behoove you to come up with a way that works best for you. So I'm going to show you 2 different ways for this one. First, you can divide both sides by 1,500 and say that means 1/2. I'll use 0.5. 1/2 equals 0.85x. And then you can do real quick in your calculator, pick numbers. So if you say, well, I'm going to say, what if x is 3? So 3 years, if you substitute x in and take 0.85 to the 3rd power, That gives me 0.614. I'm shooting for 0.5 in this case. That's too high. So say, okay, well, let's go to x equals 4. So 0.85 to the fourth gives me 0.522. Still too high. X equals 5. 0.85 to the fifth gives me 0.44. So when will it be half the original cost? Well, it's going to be somewhere between years 4 and 5. Now, some people say that is so confusing because that's decimals. Great. Then say forget that and start over and say, okay, I'm using this equation. So if x, again, we're going to use x equals 3. So I'm going to take 1,500 times 0.85 to the third power. And that gives us 921.19. Too high. Let's use x equals 4. So now I'm going to use to the fourth power. And that gives me 783.01. Still too high. If I use x equals 5, that gives me 665.56. So again, you can see it's somewhere between years 4 and 5 where we hit that. If you need pure years, you would say year 5 is when it's finally underneath. But that's kind of the two ways. You can either break it down and do decimals. If you hate decimals because it's confusing, then just use the normal formula knowing you're trying to get to 750. Number 3, a type of bacteria grows at a rate of 32% per hour. Suppose a petri dish begins with 50 bacteria cells. So we have our initial amount. Y'all, it's a percent. That means it's exponential. Hope I woke you up right there in case you were sleeping. So because it's a percent, we know it's exponential. So let's construct our model. Y equals initial amount. I start with a 1. Am I adding or subtracting? Well, the bacteria grows. That's an increase of 0.32 raised to the x. That means I add inside, so 50 times 1.32 raised to the x. Moving on. So we have our model. How many bacteria will there be in 24 hours? So if x is 24, I substitute in 50 times 1.32 raised to the 24th power. Whew, y'all, this is real fun. So exponent first, so we would have 50 times, and this is going to be roughly 783.0226935, continues on. Keep that in your calculator and then hit times 50, and we end up with roughly 39.151 bacteria. That's a comma. 39,151. Can't read my own handwriting, y'all. There's a lesson there. So 39,151 bacteria after 24 hours. All right, let's go down to letter D. How long will it take for the number of cells to double? So we started with 50, so that means we are looking for a Y value of 100. We know it's got to be less than 24 because after 24, we get into 39,000. So where do you want to start? And I don't really know, so I'm just going to say, you know what? We're going to start at x equals 5 just to see what happens. So I'm going to take 50 times 1.32 to the fifth, and that gives me 200.37. Oop, too big. Okay, we need something smaller. Let's go x equals 2. That's smaller. So 50 times 1.32 to the second gives me 87.12. That is too small. Okay, fine. Let's go to x equals 3. 50 times 1.32 to the third gives me 114.9984. Okay, so between 2 and 3 is when I get to 100. So if we need full days, we would say it takes 3 days to double. But it's really somewhere like at, I don't know, 2.5. And you could always try that. If you want to say, well, what if x is 2.5? So we would have 50 times 1.32 raised to the 2.5. I didn't do that one, so let me punch that in real quick. And that gives me, oh my gosh, that's 100.09. So you could say 2.5 days. But you don't always need to be that specific. So you just want to make sure you read the directions so you know exactly what's expected here.